Okay, we are again looking in Chapter 3, and this time we're looking at standard deviation, and this is a special type of standard deviation problem. If you viewed the previous YouTube clip that I put up on how to compute a mean from a frequency distribution, this can be considered to be an extension of that problem. We're computing a standard deviation from the summarized data in a frequency distribution. Now, again, this is on page 113, and it bears pointing out that in your textbook, there's actually no explanation whatsoever of how to do this, except on page 112, there's information that's kind of embedded in the problem set. And this is the only place that I know of where the formula actually appears in your book. So in other words, you're not going to get much mileage out of going back through this section and doing the reading and trying to figure out how to do this. It's only explained right here. Okay, so probably this is why it's a good idea that I take some time and do this problem. All right, so the formula for standard deviation from a frequency distribution, it says standard deviation is the square root of n times the summation of f times x squared minus the summation of the product of f and x, quantity squared. Divide that by sample size times sample size minus 1. So this can look a little bit intimidating, but let's really think about what it is that we're doing. First of all, each of these values are frequencies, and so the appropriate variable for that is f. If we look over here, x, remember from the previous problem that we did that x is the midpoint of each of the classes. So to compute the midpoint, what I would say is 60 plus 69 and divide that by 2. So I'm saying 60 plus 69 is 129 divided by 2 is 64.5. Okay, so the midpoint of this class is 74.5, 84.5, 94.5, 104.5, 114.5, and 124.5. And again, you can get each of these by adding up these two values. 70 plus 79 divided by 2 is 74.5. Okay, so that's the x that's up here. We know that we're going to have to multiply f times x, and we did this in the previous problem when we were computing the mean, but I'll go ahead and do it again. So what I'm doing is saying 12 times 64.5 is 774. 74.5 times 14 is 104.3. 11 times 84.5 is 932.8. Put this down so you can see it. 1 times 94.5 is 94.5. 1 times 104.5 is this. 0 times anything is 0. 1 times 124.5. Okay, so again, it's a good idea just to do a reality check. Does 12 times 64 equals a 774 make sense? Yes. 14 times 74, 1043, no decimal point. 11 times 84, that makes sense. 1 times this, 1 times this, 0 times this, 1 times that. Okay. So that's going to be this quantity here. If you remember from what we did before, we added up all these digits, and this gives us the summation of f times x. So if I say 774 plus 1, whoops, clear that, 1043 plus 932.8 plus 94.5 plus 104.5 plus 124.5. What I'm getting is 3073.3. And this quantity will go right here. So the next quantity that I need to think about is the frequency times x squared. We know that x is the midpoint. X squared is the square of each of these numbers. So 64.5 squared is 4160.25, and I'm going to do that all the way down through. 74.5 squared is 5550.25. 84.5 squared, 7140.25, 94.5 squared, 8930.25, 104.5 squared, 10920.25. This one I actually don't need to bother with, because when I multiply the f times x squared, the f is 0, and so that one will zero itself out just like it did here. And the last one is 124.5, square it, and I end up with 15500.25. And then once again I need to add that column, and that gives me the summation of f times x squared. So I'm going to go back and just add up these numbers. Plus 5550.25 plus 4160.25. And so what I have is 52201.5. Okay, now the n in this problem is the sum of the frequencies. So 12 plus 14 plus 11 plus 1 plus 1 plus 1. So the sum of the frequencies means the same thing as n. 26, 36, 37, 38, 39, 40. Okay. So now we have the numbers that we need to go in here. This is n. This is a summation of f times x, summation of f times x squared. So again, I'm filling in the blanks in the formula. I'm going to have to move it down a little bit. So underneath the radical, we have 40 times f times x squared, 52201.5, minus f times x, quantity squared, 3073.3, square that, divided by 40 times 39. Okay, so now we're going to go ahead and compute this. Okay, so what I've got is 52201.5 times 40 minus 3073.3. I'm going to square that. And I end up with a negative value, which means something's terribly, terribly wrong. Divided by 40, divided by 39. Okay. So anytime you end up with a negative value like this, you know you've made a mistake in your computation. So let's go down through here and see if I can pick this up. I'm going to try adding up this column. I think I tripped myself up when I put the decimal point there. So let me see if I add it up, if I get it right this time. 774 plus 1043 plus 932.8 plus 94.5 plus 104.5 plus 124.5. Okay, so that looks right. Let's do the other side. 4160.25 plus 5550.25 plus 7140.25 plus 8930.25 plus 10920.25 plus 15500.25. And I have 52201.5. Okay, the next place that I can check is to see if each of these squares, oh, well, this is stupid, I know what I did. What I did not do, or I failed to do, is multiply the 12 times this, and so this is the column that I should be adding, so I did miss a step completely, so let's start over and think and do it right. So I want to multiply this column and this column, so 12 times 4160. 12 times 4160.25 plus 14 times 5550.25 plus parentheses 11 times 7140.25 plus 1 times this quantity, so 8930.25 plus, and again this is times 11090.25 plus 15500.25. Okay, and this makes more sense. So this sum of this column is 241520, and again that should go here. 241,520. Multiply that by 40, and then subtract. And what I'm going to do is say parentheses 3073.3 squared. Notice this time I get a positive value, divided by 40, divided by 39, and so I have 138, and go ahead and take the square root of that, which again I'm raising to the 0.5 power. I have 11.7568. 0.681